Kirby. Okay. It's not fed yet, and definitely not gonna just let me work and stream in peace. I don't need to. All right. Good morning. Welcome. What is up, Paul Shulenik over in YouTube? Nice to see you, my friend. Oh, I see what happened. Let me. Chat window. Okay. Chat was looking all weird because the YouTube chat specifically because it wasn't. That's scared. There we go. All right. Welcome. First of all, thanks for watching. Hope y'all are having a good morning, good day, weekend. This, for anyone new, first of all, thanks for checking out the stream. If you don't know, my name is Tim. I go by FoamyGuy on GitHub and Discord. I usually work on CircuitPython stuff, generally speaking, around this time each week. Saturday mornings, 10 a.m. Central, I'm usually here streaming. Take some Saturdays off. I think was not here last week, right? But I'm back now, and I do stream most Saturdays around this time. And I am usually working on, like I said, stuff related to CircuitPython. If you don't know what that is, you can learn more about it at the main website here, circuitpython.org. It's basically a version of Python that runs on tiny computers called microcontrollers. The way it works when you use CircuitPython with these devices, most typically is you plug it into your computer with a USB cable. Lots of these devices will all have a USB port there. Plug it in with a cable to your computer. It shows up like a thumb drive. You can edit a Python code file on the thumb drive, and when you save it, the microcontroller, the actual tiny computer that's on these chips here, it will execute the Python code for you. So today I'm back on the magtag, same thing that I worked on last night. So if you want to, if you're watching this and you want kind of the prequel to what you see today, you could check out the deep dive from last night, which is where I kind of explored the existing dithering capabilities inside CircuitPython. And today I want to work on some new ones. Also, I wanted to mention this link here, which I'll read a bit more later as well. I did not see this, but this got dropped in the chat last night thanks to some nice who put this, which is good, because I was going to say this will probably help for me to kind of try to read a description of the algorithms, like kind of how they work, sort of vaguely what the variables involved are. Like they seem to have that ERR variable, which I'm assuming maybe is error rate or something like that for tracking over time to be able to round off. So anyway, thanks to Some Nice for this link. We will be checking this out in a bit. And let us also say thanks to Adafruit if you want to help support CircuitPython and lots of other open source software. One of the easiest ways to do that is by purchasing hardware from Adafruit. They pay a team of folks, including myself and some other people, to work on CircuitPython, as well as loads of other open source software. And you can support them as well as, you know, us and all the work we do on that software just by purchasing hardware from them at their website, adafruit.com. Huge thanks, as always, to them for being willing to pay people to work on open source software. I think that's obviously super cool. So I do have the mag tag. Like I said, we have this dither pulled up, and what I want to do today actually is, we can close Steam, I think, is try to implement this, try to take this implementation of dither. Floyd, this is apparently Floyd Steinberg dither. I found this online at this page here. Let me pull it up just so we are kind of like crediting where this came from. CircuitPython blog, Floyd Steinberg dithering. There's not exactly a 2-line or anything, so I don't see like a name associated with this, but BY content, Christian Hill, maybe, learning scientific programming with Python. Sounds like maybe it came from a book. Maybe this is like code that goes along with the book. In any case, they have an implementation here of this FS dither, which is notable in that it takes this NC, this number of colors argument here. I think that's what it means, and that seems to be how it works, so it's good enough for me, even if it's like perhaps not the exact right verbiage. This implementation of dithering allows you to pass in a number, and then it gives you back an image that is dithered with that many different colors in it. So the dithering that we did yesterday inside CircuitPython through the palette dither option, as well as through the bitmap tools dither, both of those were resulting in 2-color dithers, which I think is more typical. Like that's kind of the traditional dither, is, you know, essentially black and white, 2 colors. And that works, and it actually does look pretty good, as you can see from this portrait of 50 Cent that we have here. But the mag tag display actually can display up to 4 colors. There are 2 grays as well. It has black, white, and then, you know, light gray, dark gray. And I have a copy of this image that I dithered with this algorithm, which then, you know, ends up with, I know which one it's in here. So I could open it. Let me open it back over here. And this one, it's this. So this one actually uses the 4 colors, and it looks a bit better on the mag tag screen, of course, since it makes, you know, full use of all 4 colors that are available. So it gives it just a, you know, bit more sort of illusion of depth shading and stuff. Although truthfully, the 2-color one, you know, here, this is quite good, honestly. I'm impressed by what the dithering algorithms can do with 2 colors, if I'm honest about it. But that's what I'd like to do, is implement this one, which takes a number of colors into CircuitPython. We do have a bit of a challenge in that this is actually using NumPy and PIL, which we obviously don't have either of in CircuitPython. We have Microlab, you know, ULab. NumPy has like a subset of NumPy stuff, which I think will get us through what we need here. There's only really creating this array. I know what this would do if you create an array and divide it by. Actually know what that would do. Maybe let's see if ChatGPT or Claude wants to tell me Python code does. Specifically the divide by 255. Understand. So create the array, NumPy array. That's super easy, I think. Divide every pixel value in the array by 255. Interesting. Why? So it normalizes the pixel values. Okay. Interesting. Okay. Are we going to do that? Yeah, I guess we're probably going to do that. So we're going to have to do this a bit differently. This is creating an array directly from an image, which is a PIL image, which must have an interface that allows it to support this kind of thing that's happening. Our image is a bitmap image. We don't have PIL, obviously, inside the microcontroller. We're not going to be able to just directly create an array out of an image, I don't think. But there is some stuff that's going to help us. There's array blit. So this takes pixels from data, which I believe could be an array, a microlab array, ULab type thing, NumPy. But this is putting it into the bitmap, so I think we want this later. Read into, it's from a binary file into a bitmap. This is also not really what we want, I don't think. So I guess we might have to, it's going to be slow, I presume, but we might have to like loop it and put it into an array. So I am not necessarily aiming for speed here. I am going to do this at the Python level, knowing that it's going to be slower than if we were to do it in C, obviously. And I would like to, at some point, work up to maybe being able to do this from C inside bitmap tools or somewhere. But to start with, like, to wrap my own head around it, Python implementation is going to be quite helpful, I think. So let's first get this out of the way because we can't use it, and let's fix our NumPy thing here. I think we can do... So I think it's like... Basically that would work instead. For a lot of stuff. Not everything, but for a lot of stuff. And the most basic stuff, I believe, is covered. And this seems to be not doing anything too on-basic, although I say that as round is also not filled in here. It looks like we don't have round, so we're going to have to solve that problem. We do have array. Type. Sure if that's gonna work still or not. So this is also creating an image from the array, which is another thing that we can't really do in CircuitPython, right? This is a PIL concept of being able to take an array or a NumPy array, turn it into an image from the data that is inside that array. I think what we'll do is let's make this kind of follow the interface of, kind of follow the interface of the bitmap tools one. What's up, Yano? Nice to see you today, my friend. I am doing pretty well. So I think we could do this kind of the same way. Dest bitmap, source bitmap. I'm not sure why. my head wrapped around exactly why it needs color space. Exactly. Getting an RGB. I don't know. Well, I guess we'll take that eventually, but I don't have my head wrapped around how it's used by the dither algorithm. And then I'm actually just going to start with only the one that I have, the Floyd-Steinberg, which is what it says it is. I wouldn't necessarily know enough to say if that's for sure accurate or not. But I take it at its word for now. Dest bitmaps, so it does go in this order, right? Yeah, dest bitmap, source bitmap. Calls them the full name, so I guess I'll do that as well. And I think I'm just going to stick there for now. We'll add the other ones eventually, maybe. But then we still do also have this NC, this number of colors here. So in order to get our image into the array, I don't think we're going to be able to do this, but let's try. These would be... It doesn't matter, honestly. I think the rule is going to be they have to be the same. They are assumed to be the same going in, let's say. Although it does say new height. New width? I'm not sure why they call it new, honestly. But I think for now, I'm definitely focused on source bitmap and dest bitmap, same size. If not, then like on your own. Might not work, might break, might raise an exception, might do something weird, I don't know. But for now, I'm good with that assumption. Have dest bitmap. So at the end, we're going to want to, I think just instead of returning, at the end, we're going to want to put everything from the array into the dest bitmap, which we can do with ArrayBlit, map tools ArrayBlit. So that takes the bitmap and then the data and location, but I think we can use defaults because we want the whole thing. Not going to return anything. We're just going to bitmap tools, ArrayBlit. Be nice. Well, we'll see if the one up there works. Maybe we can actually create the array from the bitmap like this. I kind of doubt this is going to work, but it would be cool if it does. ArrayBlit, the destination bitmap with the data that comes from car. I don't know if that's C array or I'm not sure. Color array, maybe? I'm not sure why they called it that. ArrayBlit. So let's just if this. Back up. Because usually that means that the storage is 8. Is this still sleeping? And let's bring it back to a while true pass. Except I can't save, obviously. Let me also copy this. But I will say this was doing this weird thing where it didn't seem like it should be connected to my computer, and it was. Okay. That's running now. It seemed to save. Camera died, of course, because everything just... Actually, I'm gonna get a new camera, I think, for this one. Some new camera. This one. I don't have it yet, so now we... Yeah, definitely a new one's gonna be good, because this is getting on me. One's dead again. What is up, C. Grover? Nice to see you, my friend. Coffee cheers. Okay, so this at least ran. There's no like syntax error. We'll see when we try to call this. FS dither, dithered bitmap, photo bitmap, number of colors 4. And convert type to int. 33. Is that where we create the array? Yeah, totally. But actually, it's kind of mad about this thing. Maybe. Can't convert type to int. So it almost seems like dtype wants an int and not a type. So maybe that's a difference in the actual implementation. No music. Oops. Hang out of the speakers. Connect these? On? It is not. But array. I think we want to be using one of these instead. So ulab numpy.float. Or in our case, just mp.float, because we already imported it that way. Okay, bitmap object is not iterable. So that is the array thing. That is now, I believe, an error of this is expecting an iterable thing and this is not iterable, which is a shame because it is like, it might as well be. It has square bracket access. You can, I believe you can even access it. Like you can definitely access it with square brackets XY. I'm pretty sure you can even access it with just square brackets, you know, I, so to say. And it will do the modulo for you essentially if you just keep giving it indexes. So we could try to make, we can try to make it iterable, or we can load the array some other way. It feels like it shouldn't be too hard to make it iterable. What all does that entail? Python, how to make iterable object. What is up, VP Tech Ops? Nice to see you, my friend. Implement the iter method, return self. Oh, and next. And iterate, if it can be iterated over, using a for loop to make it iterable, primarily you need to implement one of the following methods. Iter method should return an iterator object. An iterator is an object that implements next. Okay, so you need one of the following methods. Maybe they're going to list more methods. Okay. Just get item. So I'm pretty sure we have this. Maybe this doesn't work for us, but I'm pretty sure it does do this already. We could dir and see. I think maybe if we just implement iter and next on this class and correctly pull data out of the bitmap inside of next, it should maybe work. But I'm actually also curious about bitmap. What all does this show? Actually, it doesn't show a get item. Does it not work for getting? I'm pretty sure you can get with that though, right? Uh, print source bitmap 0. Yeah. So it doesn't like outwardly show in dir that it has get item, but it definitely does because this works. I mean, maybe not definitely does. It functionally does. No, boy, that's early today. We didn't even make it 30 minutes in before we got the old "you want to buy" viewers. I do not want to ban people who ask, though. So this is weird that you need iter to return self. I'm not sure why that's a thing. Should have an index. We already have data, essentially, is the bitmap in our case. Length. I don't know if we can do length, actually. Let's try to find out. That we might not be able to do. But we can easily calculate it even if we can't because, yeah. We can't do that, but we can still easily calculate it because the length is going to be width times height, right? It's a 2D array. I have shape. I'm guessing that's a PIL thing, probably. We don't want comma, though. We want to multiply. Duration, so self dot bitmap item index return. Okay, I think that should work. So iterable bitmap. So let's create one of those out of source bitmap. Iter bmp equals iterable from source, and then let's use that here. Really need these right now. And then see if we get farther. Necessarily expect it to just work, but see if we get farther. Kind of the oh. That's not ideal. It seems like hard crash type thing. Did I do this wrong? That's also bad because it's in my CodePy and I'm gonna keep doing that. So we need to get to safe mode or else we are basically soft locked for now. Which I did not realize we were at risk of. Apparently we are. Now that I know that, I guess I will need to I should put time.sleep at the beginning of that so that we have time to connect and stop the program. So there is a window, I believe there's a window where you can get to safe mode. Yeah, we might, oh, no. Shoot. So we connected, but only for a split second. Oh, that's frustrating, kind of. But we still have it a lot easier than microcontroller development. So there's supposed to be a cadence where you can actually get safe mode, and if we get to safe mode, then it won't launch CodePy, which means it won't hard crash, which means we can get back control of our thing here. But I don't really know what the cadence is exactly, truthfully. I don't usually do it this way. I'm pretty sure there's like... that twice somehow? Hmm. Doesn't actually say how to get to it, though. I mean, it implies here there's a button press. Here we go. During the blinks. On other boards, you'll enter it if you hold down. Your playground, you hold those. I'm gonna try to ask if anyone knows how to find the definitive way. It would be nice to be trying something that should work instead of just trying a bunch of things to try to find out what works. Nimble out of memory. What is nimble? I don't know what nimble is, but I mean, it's out of memory potentially. Safe mode. It did say blink. I tried to do a couple of times, honestly. Now let me try this. So during the yellow blinks, so if we could see it connect, maybe I can... Oh, it's so fast. gonna say if we see it connect here, maybe I can control C it real fast, but not working because it does feel like there's a split second between the time when it connects and it hard faults or whatever it's doing to disconnect. We just spam Control C. Oh, like we were closer that time. I was spamming Control C, but it didn't end up mattering. So if I press it during purple, then we get bootloader mode. Every time. Oh, I think I got a reply. There's not, and that's a problem. Flowchart has various modes here. Right. Yeah, I do remember this actually. Is there a way to look at the code and find out? The text. Hard to search for. Flowchart for various modes. Code. Where's safe mode? So bootloader mode. If you press reset during this window, and if the USB is connected, you go to what I will refer to as bootloader mode, where your NeoPixel is going to blink red and then go to green, and it's going to be ready for you to put a UF2 file. If you don't have the USB connected, it'll stay red, apparently. I don't know if I've ever seen that state, but I believe it exists. You don't press reset during the bootloader, which I believe is purple on the LED on this board at the very least, and I think some others, but not all. Then it goes here, user code, either Arduino or CircuitPython. CircuitPython starts, the bootloader waits 700 milliseconds for reset. RGB is yellow, and red blink, the LED on LED blinks 3 times. Well, it's not an on LED. Is it? I don't think so. Because that's just wired to power. It's the LED, like board.LED, E13 LED. So this is going to yellow. If reset, then safe mode. Reset pushed, then it just goes to safe mode. Reset not pushed, it goes to user code. So theoretically, 500 milliseconds for bootloader, and then 700 milliseconds after that for safe mode. A few more tries, I guess. So they go purple, and then they go yellow blink. And there is a D13. Let me watch what. So it does turn red. It can be difficult to react to the yellow. Give it as a slow. Troubleshooting. Missed the troubleshooting page. On the mag tag. Went to mag tag, I thought, a second ago. Slow double click. Remember, the fast double click goes to the bootloader. Yeah, so we gotta, like, that's the trick on this one, is kind of like well, on a bunch of them, I suppose, is... But I feel like I've been doing that. Where did you find that? Learn magtag. I almost wish, well, I almost wish it was like tied to other buttons. There's settings in there. Oh, and there is one of these. Or was this the same page? No, this is welcome to CircuitPython, but I think it's the same image. Multiple times for 1 second. Pressing the reset or on a expressive. I would argue this wording is a little bit weird for this page, right? Because this is a page about the mag tag. It definitely is expressive because that's the only one that exists currently. But that, I think, actually does tell us what we need right there. I think we actually need reset and then boot. I think I've actually discovered before and then forgotten. So I think we need to go reset button, and then during the yellows, I think we actually need to press boot. I get it that time. Oh. Yellow stopped. Ah, yes. There we go. Safe mode. Awesome. Thank you. By the way, yeah, no, that page got me information I needed. I really appreciate the link. Let's see what Dan. Settings. Ooh, interesting. Be cool to go look at the implementation as well. Okay, so yeah, now we got out of safe mode, which is good. Or we got into safe mode, which is good. We got out of soft lock. It's good. Now the problem though is like what I was trying to do got us soft locked. So do I want to go off track and try to submit this to CircuitPython repo now as a bug? So this is in. Try to make this minimally reproducible. So to start with, I don't think I actually, do I want to do that? I don't think. Just do that. We'll double up once that we're turned off. Let's get this file entirely commented. That way it's not going to run on boot up and it's not going to keep us in a locked state for now. And then let's make a file, if I can get my mouse to cooperate, called like crash.py. And let's try to figure out what is the minimal set that we need from this cause the crash. Now I'm kind of suspecting that it's going to be this and then the constructor for this. Well, for the array, actually, truthfully, not the this part. Need a source bitmap though. Hopefully this doesn't need to be fancy. Like, my suspicion is as soon as we do this, it probably crashes. Because, like, most likely there's something unhappy between the fact that this is, like, overriding and providing these, and then this is trying to use them. They're probably not actually working correctly somehow, somewhere. My first guess. So this is now in crash. So I can now import crash, and it will run that. And if it hard faults, if it hard faults, then it hard faults, no problem, because I can just reset once, and then it's going to boot back up and not run. It actually rebooted itself. Is it actually in safe mode? In safe. Well, but I was in safe mode. Do I want to be? I think I actually want. Let's try resetting once to get out of safe mode. So then, you know, it's going to try to launch CodePy, but I commented it out, so there's nothing there. And then here, I mean, I don't think it should matter. So it does disconnects, but it actually reconnects. So the behavior is slightly different this way. Because the other way, it was crash, gone, didn't come back. Now it's hard crash into safe mode, whatever this thing says. A little hard to read. Memory access error. It's a shame that we didn't get connected fast enough here for me to be able to copy paste that. Okay, I do think this is enough to report, though. And I suspect the other one is probably effectively the same problem. And just to make sure, take this out, it does not crash, right? Sample code included brackets. So your code would need iterable bitmap with brackets. Here? I don't remember using brackets. Sure, what you mean. So let's try this one. Guessing, yeah, after create. So this one does not fail. So the subclass, well, it's not really a subclass, I guess, but this thing is fine. Let's make, does it work? So can we just say for, you know, whatever, underscore in iter bitmap, just print underscore? That works. Yeah, that works. Okay, so that does give us an iterable bitmap. Seems fine, that part of it. But then the array, it's very unhappy. Halfway unhappy now. Was very unhappy before. Huh? Is that a thing? I don't know if that's actually a thing or not. Plot thickens. If you iterate through it, it doesn't crash. Fascinating. Okay. Huh. Okay. That is weird. So, yeah, that's super weird. I don't know. I wonder if we get rid of this. Is it still unhappy? Because we could just split that if maybe it doesn't like doing both. No, okay. Creating the array, let's crash it. And iterating before you create the array makes it not crash. I don't know what this is supposed to be. I don't. So that seems wrong. Seems a little bit wrong, but you don't really have this, I guess. If it gets correct value out, doesn't. I don't. This didn't seem to work, honestly. So maybe let's give up on using this for dithering, and instead we will just slowly manually copy the bitmap data into an array that we create. But this should totally still get reported, I think, as a hard fault, right? Because whatever's making it hard fault should get fixed. And hopefully fixing it will cause it to not do the even harder hard fault before that we saw before, where it didn't even manage to reset. It does have memory. Oh, right. Or it didn't do it last time. Save the code yet? Unfortunately, I can't copy it from here because it basically, this comes up and it prints what it prints, and it's, theoretically it sends it in serial, but the TO is not connected yet. So by the time it connects, this is already gone. Core crashed hard fault, memory access or instruction error. Memory access or instruction error. Faults with memory access or instruction error. Interestingly, the print iteration loop for the array is uncommented. It no longer faults. It's either, but that is a separate issue. Less severe, I would argue. A separate, less severe. It's minimal reproducer. Trying to use similar code in the actual image, and the mag hard crashed but did not reset itself back into mode. Stayed crashed. Disconnected. Let's see. Cover with manual access. Smaller producer be able itself back in mode automatically though. Hard fault. Yeah, I did know this, but I didn't have REPL yet. These boards have non-standard. Interesting. That's cool. Repped for ones that are different. Playgrounds and third-party stuff. Unexpected Maker, I have a couple of those, but the rest of these I don't actually have much of. PXs are the only boards we make here that would be documented by us. Well, this would be nice actually. Say on downloads page and or board specific guides. Particular, it would be nice to know for any given board it's double press set or press versus set. Yeah, word separate. Manual. Okay, this is documented. I don't want to keep digging too far into that because I really want to work on the dithering more than the why did this hard fault type thing. But that's at least documented now, so it can be looked at, worked on later. I'm going to go put up the sun blocker, so I'll be right back. Reached the time of the year where the sun likes to come in and hit the floor over there and then shine directly into my eyeballs. I do not. Trying to work. Okay. All right, so let's get back to here. Let's add a time.sleep 5 seconds. And it should just work because we already imported time up there. Let me also take this out for now. Or really, let's just create an array that's the size we need holding bogus data for now. How do we create an array successfully? We say array, can I just give it a size or values? Constructor for ND array. Always taking values. Okay, so we could say buff equals a list of 0 times the source bitmap width times source bitmap height plus 1. So that should make a list with this many elements in it. So then put that as this. And then in a little while, maybe we'll come back and worry about filling this buffer up with data from the bitmap. But for right now, it'll just have all zeros. The rest of this will probably not do anything terribly interesting to it. Hopefully it will at least not crash, though. Somewhere there's also round, which will theoretically crash, I think, because we don't have it implemented, I don't think. So we are currently in safe mode. Means when I saved this, it didn't actually run CircuitPy. Why is that? I will switch back to here, portrait mode, reset once to go back to regular mode. This is going to run CircuitPy. It does now have time.sleep here, so it's going to wait 5 seconds before it does anything. It's also, but annoyingly, going to close in my IDE. Many indices. Too many indices? What does that mean? See the files? Indices, line 59. I like to copy out of this. Okay, so this is trying to make a 2-dimensional array, but this is a 1-dimensional array. So somewhat annoyingly, we actually need row equals a list of 0 times the width, parentheses, and then the buffer, the full buffer, will be row, which is now a list of zeros times the height. So we have a list of lists of zeros. It is same shape as the bitmap. Any indices? NB. I don't know what NB means. Need to copy here for RGB arrays, otherwise error will be 000. Isn't there a shape? Not two-dimensional. Or maybe it is two-dimensional, but it doesn't. No, but it should be rows. So like the length of the first dimension should be number of rows, which should be like 200 and something. I think the image is maybe 230 or 240 pixels or something like that. 202? Is this 202 times 128? Yes. Does that work? This crashed on line 55 now? I'm not sure if this part makes the error or if copy makes the error. 55. This makes the error. I mean, we could just multiply these. I don't know if we're just not allowed. Well, let's look at buff, I guess. Is buff the correct shape, so to speak? Buff should be 190 rows, or 202 rows that each contain 128 zeros. And it should be a list of lists, but it's not. It's only a single list. That did not work, actually. Oh. Buff equals this, maybe? It made a difference, but it didn't actually do what I wanted, right? So now we just have one list that contains another list. Really, we need one list that contains 202 other lists. Kind of annoying. Okay, so row. So we have a row. So let's just say for I in range, buff is a list. Buff dot append row. You have a row that's 128 zeros in a list. We then add that list to this other list height times 202 times. Okay, now we're getting somewhere. Now we have a buffer that is the right shape, and we have an array, a numpad array. Numpad? NumPy array that is also the correct shape. Now the next problem is float has no copy. Line 64, float has no copy. Which is fair, because float doesn't have copy. So why... We need copy here for RGB arrays. I don't know what that means. Otherwise, RGB arrays will be zeros. Yeah, I don't really understand why. How would copy make a difference for the value? Like, if we needed to make sure to not... Is it not a value? Normally? Like, if you just reference it like this and then put it in old val and then change old val, does that change what's in the array? And thus copy makes that not happen? It makes it so that now we have a new thing, old val, and when we change it, it doesn't affect what's in the array? That feels like it would be awkward as its default behavior, though, honestly. What happens if we just don't copy? I mean, that should be looking up a single value, right? That should be getting one value out of the array. I don't really see why it would need to copy that value. Okay. I mean, that let us get farther. And now we have made it to where we do not actually have a round function. So we would have gotten in here called get new value. This would have gone into here and tried to do np.round, but that doesn't exist. Is there math.round? That bad to use? Or is there just round? There's a round thing. Round by itself. But is np round different than that? What does np round do? A round? Do we have a round? Got it, right? Second. Can I dir np somewhere? Back out? I guess I could have done that in the REPL. No. We have a range, we have arctan, we have argmax, argmin, argsort. Actually, we do have a round. Fair enough. Fair enough. So are those actually literally the same? This thing telling me the truth? All right. That would be convenient. And we do still have bogus data here, so not actually going to show our picture even if all of this works. First argument must be an array. Get the closest color to old val. Okay, I'll be right back. I think that's trying to operate on the entire array at once, but we're not giving it an array, we're giving it old val as a single val. So we could put it into a list? Or no? BRB. separate boot button. That's usually to get into the ROM bootloader. Double pressing is the most common. Yeah. If there's another button, it's like convenient, but not every board has another button. Okay, so I think like this is wanting to operate on an array. This feels super wasteful to make an array specifically for this one thing, but I'm gonna see if it's at least. So this was rounding, then it's dividing after. So we actually want this here. So we make a list with the one value we want in it. We put that one value into a numpad array. Numpad, I just did numpad again. Then we can call a round on our what is now an array. But presumably that's going to give us back an array, I assume. So we want the first element from that, which should be the actual rounded value, which we then actually divide. We could stop printing this, and also maybe this, although that one's less problematic. It prints one thing. Oh yeah, we don't need that dir either, actually. Okay. Okay. I was gonna say I don't really know how long to expect it to take. But we made it to the end of the loop, so that's how long it took. It was, you know, a couple seconds. Definitely slower than PIL, but is a microcontroller. And we are, you know, I imagine doing this orders of magnitude slower than if it were in C code, especially because we're like creating an array that we don't really need. Curious if we can maybe just use regular round, but I want to try to keep it as close as we can to the original code, and then hopefully we can get an outcome that looks like the original outcome, and then we can start like, okay, can I change this to be more efficient? It says access must be none or an integer. Access. It must be none or an integer. So what is access? I just typed notepad. So that's not going to go away anytime soon. There's no access. No access. np.array access equals. Oh, this is to max. I.max. Access. None or int or tuple events. Axis or axes along which to operate. By default, latent input is used. This is a tuple of ints. The maximum is selected over multiple axes instead of a single axis or all of the axes before. I have no idea what that means. Return the maximum of an array or the maximum along an axis. I have no idea what that means. Shall we try another one here? What is the axis argument from this statement? Compute the maximum value over axes 0 and 1, but not axis 2. But what are those? What are axes? Does that mean x and y? Image array shaped like with channels. Pixels, yeah, I think this is x and y. I divide by that. Okay, this part I don't, not 2 yet. I don't really care why I divide by it just now. Okay, what's the closest thing we have? If anything. Axis, it's an int. Okay. So it's allowing you to find the maximum of a two-dimensional array in this case. It is somewhat unfortunate that we don't have, but we can certainly def max 2D array x equals none. Or max I, so get the list, get the row, this row max equals that if max is none, or is it less than, greater than row max. So if this is none, or if the current one, okay, I did, yeah, backwards. If the current one is bigger, then update the current one to be the row one. So go through all the rows, finding the max of each row, and then comparing to the total max to find the total max and then return it. X2D of R. And I do also still have the time.sleep 5. I guess we get to see though, because that stuff prints after. It might be nice to have something printing here or after this, maybe. It does, like I said earlier, it does seem to take it several seconds here. And I assume at this point we're kind of like still in this loop. Value must fit in 1 bytes. 89. So divided by I think it's five. So I almost am wondering if our problem is that the original code, I think this original code might have been expecting to operate on like RGB tuples. In which case R would be 0 to 255, you know, G would be 0 to 255, and B would be 0 to 255. So each color individually would be 1 byte. But that's not, in our case, we're not actually working on that. We saw, it's been a while since we had the actual image, but when I printed a pixel from the actual image, what we have are larger values. They're essentially hex RGB values. They're converted back to decimal rather than being expressed in hex, but they're not RGB tuples, and they don't conform to 0 to 255. They would conform to like 0 to whatever the maximum of 6, like whatever 6 Fs in hex is. What's up, Gordy G, over on the YouTube chat? Nice to see you, my friend. So that, yeah, I don't think this can really work. Is there a uint32? Is that a thing? Or is that just int? Lib.numpy as np dir np. There is no... There's int 8, there's int 16, there's INF, which I am guessing is infinity. I thought all those things were called D-type, though. Wasn't there a D-type? D-type. D-type. They have a type of D-type. I mean, we could try this. I don't think that's gonna fit either. For 565, I guess it would. I don't think that's... I'm not sure that's what we have. Sure, we have RGB full. Maybe not, though. Maybe it's automatically converted somehow. It's automatically converted somehow. Not, I guess we got a color converter. Slower. So we can't have a NumPy array that holds... We can't have a NumPy array that holds Python integer sized values? Because a Python integer can store like I equals this. What if we just don't do a data type? Okay, it didn't crash. We have a rectangle. Okay. What if we actually put data from the image into buffer here? Is there fill row? What does fill row do? That's on bitmap, I think. I would love to not iterate every pixel. Where is duplicate tab? I think I tried doing display.bitmap yesterday and it didn't up. Type. Huh. This sounds like what we needed to use. From buffer. Lab.numpy.from buffer. From buffer. Not documented. But there is here. Okay. What does it do? Documented. Numpy from buffer. Interpret a buffer as a one-dimensional array. We want a two-dimensional array, though. I mean, we could rework this code to operate on one-dimensional. I'm not sure if it's like... Afternoon, how goes the coding? Pretty good. Official Shammer over on Twitch. I don't want to be a negative Nancy, but I really hope you don't just try to sell me followers or artwork or really anything, because I don't really want to buy anything from person in the Twitch chat. But I welcome you. Thank you for watching. And I hope that you don't try to sell me something. But as you might have guessed from my reaction, it is unfortunately a bit common on Twitch that people come in and drop a sort of what's up type message like that. Nice. That is awesome. Thanks for hanging out then. We are a bit deep in the weeds here. We're making some progress. Learning and you're only 8 hours in. Wow, okay, so you're just getting going. You're at the beginning of your journey, my friend. Alright, we'll worry about from buffer later. Maybe, it seems like possibly this could be a better way to load data from the bitmap into the NumPy array. But it does also seem like it's going to be a one-dimensional array, and the rest of this code kind of wants to be operating on a two-dimensional array right now, so... Not going to bother trying to change it at this point. I swear there's a fill row, though. Is that not a thing? I swear fill row exists. It's not on bitmap, though. It's on something else. Can't use it. Okay. Well, not on bitmap. Group, I think. Group either. File group. Let's look at bitmap saver. This is the thing that uses it. I'm aware of. GitHub for it. Saver. Fill row. Pixel source.fill row. And this totally does seemingly take data out of a bitmap and put it into a byte array. We could then hopefully get into NumPy. So is just fill row exist on bitmap, but also is not documented? We find two things not documented. Walked away from the computer because I failed a simple for loop comparing to an array for an hour. LOL, had to have AI assist. Self-shame. I wouldn't be worried about that too much, honestly. If you're 8 hours in, like, there's gonna be a lot of stuff that is really hard to do, honestly. And you gotta just kind of keep at it. But breaks, I would say breaks are good too. Like, a lot of times when code is not doing what you want, take a break, take a walk, do something else for a while, come back to it, and with fresh eyes, errors and issues have a way of popping out at you a little bit differently after you've been doing something else for a while. I definitely do have that experience with coding. So there is a fill, but that's not fill row. That's a different thing, and it definitely does not do the same thing. And there is definitely no fill row on this whole page, but it seems as though dir source bitmap. Where's the other print dir thing? At the beginning, I think, right? That one off. It seems like, based on the bitmap saver code, that there is actually a fill row. It's just not documented. But it's not there. That is fascinating. Did I miss something in this? So pixel source is a union of bitmap, bus display, frame buffer display. So this can be a bitmap, and this is display.io bitmap. It's the only bitmap we have. Pixel source can be a bitmap. Here we go. Pixel source, byte pixels, gets a pixel source, which can be a bitmap. Ah, okay. Did not read the code. If it is a bitmap, it does not use fill row. It does use a loop. Should be 2 loops though, right? Hmm. Oh, there's the other loop. Okay, it is 2 loops. It's like, I swear this needs to be 2 loops for this to work. But that is definitely just go next Y. All right, well, we'll do that for now. Yeah, all right. So we don't need this. Not working. Really need that anymore. All right, so for, say, I in range source bitmap width times source bitmap height buffer I equals source bitmap, get that pixel out of there, that into the buffer. So painstakingly and slowly copy from the bitmap into the buffer. And then get an index out of bounds, because buffer is two-dimensional, as I literally just noted a moment ago. We need two loops. Why that was such a difficult concept for me to remember for 45 seconds, but here we are. And we don't actually need this one, but we do want XY. And also, this doesn't like this. On X. This, I'm not sure, this might be like a CircuitPython. It's like two-dimensional arrays, I don't think work that way. X out of range 72. Let's look at index out of range. Are we out of range on the source bitmap or the... these are backwards. Those should still be XY. Hasn't crashed yet. Should probably go back and put some print statements with like updates of where it got to, because right now we have just kind of a wait for a very long time while it does whatever it's doing. Okay, we got something. It obviously is not a picture of 50 Cent, and it also does not have all four colors used. It has only used white and black, but it's not crashing. It's doing something now. Yeah. I think that it's likely still not... I think that it's likely still expecting to be working on an image which at each... Basically, I think that it believes like the code is written so that every cell inside of the array... Oh, but it says float. I get the sense that it's actually expecting 3 values, red, green, blue, as a tuple or whatever. Not. Those are floats. Hmm. Okay, I see one problem right away. Did I take out that divide by 255 forever ago and then never put it back? No, it's still here. Huh. I don't think that worked. So it looks to me like we actually have values between 0 and 255, but we really want values between 0 and 1. Or else we need to change the code somewhere else, but realistically we should probably try to get it to where they are basically the same as this one, or between 0 and 250, or 0 and 1. Which I think is what this was supposed to do. Would appear to have worked. Or well, it worked. 255 squared. Do we just need to divide again? Okay. I mean, that gives us values between 1 and 0. I'm going to stop this early and take out the print and then let it run. Since it still takes forever, but takes slightly less forever. We're not printing literally every single pixel. The new line for each one. Ooh. Nope. So we got something different than last time. Still not using... Still only using 2 colors. Looks pretty cool right here, though. Like a maze. Pretty dope. Okay. Would we need to multiply it twice also? Twice also. Like kind of a long shot, but sort of makes sense. Divide it twice. We basically need to get it back up to the range of hex colors, and then split it back into the destination bitmap as hex colors. Honestly, we don't really want... So destination bitmap is... Yeah. So one issue that we have here actually is that I believe this code is wanting to operate on full RGB images, essentially. And we actually want to get down to indexed. And right now there's nothing that's like doing that anywhere. And therefore it's not working. Because only, so once we get to dithered bitmap, which is the destination bitmap for this function, once we have dithered bitmap and we put it in a tile grid, we use this pixel shader with it, and we show it on the display, only the index values 0, 1, 2, 3 of color. So in that bitmap, it's a two-dimensional array. Every cell holds an integer, which is an index, and that index goes into the palette, or in this case, we're calling it pixel shader. Only the values 0 through 3 will do anything useful. All the rest of the values will just be black, I think, or perhaps white, I'm not sure. In any case, they won't do anything interesting or useful. Technically, this palette says it goes up to this amount of colors, and we're just not using any except the first 4. But I think that this whole operation here is likely giving us I think that this operation is giving us RGB values. Even if, like, assuming that this has been done correctly, which I'm not positive that it has, but if it has, I still think we're getting RGB values. Like, if we were to hexify it, we would expect something in the range of, you know, X0 to XFFFF, 6Fs. Let's take a look at the shape and the first element to see if it's a pixel or a list. One thing, because I'm not sure if it's two-dimensional or what. That'll be the first one, so we'll have to wait until a while. Okay. All right, those are way too big. Are they? Actually, I'm not sure if they are. Maybe they're not, actually. Hold on. Let's take this. X that. I don't think that's right. Maybe 565, like maybe in 565 land, that is still a gray. I feel like I found a website once. Maybe 565. Their picker. Yeah, I don't think that's right. Get that out of there. See what we get this time. It up on float 32. Interesting. Okay, so we can do a float 32. Do we get the full range? I don't know. We probably don't get the full range for integers, though, right? Like some of it's going to be after the decimal? 85? I don't think that's right either. I don't think that's right. Good check. What is 85 hex? I still don't think that's going to be gray, is it? Blue now. Yeah. All right. The way that this was doing uint 8 makes it feel like for sure this array was actually expecting each cell to be one color channel. Like, each cell in this is either red or green or blue. And in my code, each cell is actually all, right? It's the full pixel. Red, green, blue are all in one value. I think of it as a hex color value, but obviously it exists in decimal as well. And then, you know, also divided down to be between 0 and 1 instead of 0 and FFFFF. I think that this is likely not correct. How I just tacked on another one of these. It got it down to the correct range. Maybe it is, but I'm not actually. I don't really think it is, honestly. But I think the crux of this is, realistically, this needs to be rewritten a bit more substantially to not be expecting these individual channels to be broken out. You know, or / the other option is we need to break out those individual channels. Extra silly in my case because we have a grayscale thing, so they're going to be all the same anyway, but the way the code seems to be wanting to operate is those are individual. I think we would have to do that. But I have learned a lot. We were not successful. Obviously, we don't have 50 Cent here. We have weird, still pretty cool looking maze static, though, I will say. Like, I don't know how it came out with this, but that looks pretty cool. Not successful, but I learned a lot, and I think I have at least a little bit of an idea of where we actually need to head next. I think probably what I'll do is I will sit back down with the original implementation of this. I've done a bunch of changing now to get it to at least execute in CircuitPython, right? We changed a bunch of NumPy stuff to be ULab stuff. That kind of thing we're still going to need, but the core logic of this, I think, needs to be rewritten to not be expecting those broken out values, or else we need to break those values out on the CircuitPython side before we pass it into this thing, or at the beginning of this thing, one or the other. So yeah, I think that's where I'll leave it today. No success, but learned a lot and have some ideas for the next attempt. I am going to head out for now, so thank you to everyone for watching. I hope you all have a good rest of your day, a good weekend, all that stuff. And I should be back for the normal streams next week, deep dive on Friday, and I should be back on Saturday for my stream as well. So I will see you then. So long, thanks for watching, and